Okay, this meeting is being recorded. Yeah.
Okay, now the recording is starting. But you cannot share a screen, I guess, right?
Yeah, I'm sharing, right? Can you see it?
Oh, you're already sharing. Yeah, that's nice. Okay, good. So you share and then you give me the host back. Okay, that's nice. Yeah, let's go. We can start.
Okay,
Mm-hmm.
so I had to find the town judge, which basically they gave me and people and an array of pairs with trust. So the person with the index A trust the person with the index B, and the town judge trusts nobody, and everybody except for the town judge trusts the town judge. So I needed to find the only person that satisfies properties one and two.
Mm-hmm.
So it's kind of weird. There is exactly one person, but it says that you can return -1. So maybe there's one or zero people that
Yeah, yeah.
satisfy that condition. What I thought I would do was a graph, an an ordered graph with the trust between the people.
Mm-hmm.
Wait,
Yeah, I can see.
yeah.
Yeah, yeah.
So I made an adjacency matrix,
Mm-hmm.
mm, with size n. Then I populated it. So it went through the trust array,
Mm-hmm.
and yeah, basically it populated the adjacency matrix. Then my plan was to have two for loops, one that went through to check that everyone trusted someone. So a whole row had to be true except for that person's slot, because
Yeah.
everyone except the town judge. And then another for loop to make sure that the column of the town judge was all false. So that way I knew that the town judge didn't trust anyone.
Yeah.
But then I was thinking about saving the number of people someone trusted in a vector, and then I needed to make another vector to to make sure that the judge doesn't trust anyone. So it got very complicated, and I spent like an hour and a half, but I couldn't manage to do it.
Okay. So first of all, the idea is correct, and that's the idea. You have found the idea. Now you need to know how to implement.
Mhm.
So I mean, you're done with the idea part because it's an important part of solving a problem, and sometimes some people can struggle with the idea itself, even though they can implement and debug and stuff like that. So for you, the idea is correct, but the implementation, the way you're implementing it, is not very practical. You can
Mhm.
use some other methods to make it easier to implement, even though that you can do it like this. I mean, it's feasible. The implementation doesn't look very complicated. You just have to go over every judge and then iterate over the list of people he trusts, and then you iterate over the list of people that are trusted by him. You can do that, and the implementation is not complicated. I think you agree with me on this point, right? Yeah, but you can do better. Hold on. Let's. Can I have access?
Oh yeah, approved.
Okay, so we have n equal to 1,000. So if you iterate over the judges, not the judges, I mean the people. and then over the list of people that this person trusts, and then the list of people that are trusted by him. That is gonna be n to the 3, right?
Mhm.
And n to the 3 doesn't pass, even though it's a correct solution. It doesn't pass. It's gonna give you time limit exceeded. You're on with me on this point, right?
Yeah, yeah.
Okay. So there's a trick that you can use that's called in degrees and out degrees. So create a vector or an array for each
Oh, sorry. I was moving the Zoom.
for each of these properties. Okay, so now let's suppose that you have the in degrees and the out degrees. You know what they mean, right, in the graph theory?
Yeah. So in degrees are the number of nodes that point to another node,
Yeah,
and the out degree is the number of nodes that that node points out to.
yeah, that's right.
Mhm.
Exactly. So, if you suppose you have that, how would you solve the problem?
Okay. So the judge would have an in degree of would have n minus one in degrees and zero out degrees, or like would have an in degree of n minus one and an out degree of zero.
Exactly. That's it.
Uh, okay, okay.
So now the question is how to build in degrees and out degrees, right?
Mhm.
Do you have any idea how to build them?
Wait. Mm, go through the adjacency matrix and no, no, I, I don't.
Really?
Wait, okay. So go through the adjacency matrix and
Why does you have to go on the HHC matrix?
to to visit the a row. So if we want to find the in degrees, are the row, and the out degrees are the column.
Yeah. Okay, I have also another question. Why did you use adjacency matrix, not adjacency list?
Because I forgot how to implement a graph, and the adjacency matrix was like the simplest, or like the easiest to implement, and it was the only one that I kinda remembered. So
Hmm, I see. Actually, the adjacency list is way easier, in my opinion. It's actually way, way easier.
is
So
that I forgot.
it's fine. Okay, there's uh, so what you have is this list of edges, right? The trust you have is a list AB, representing that the person labeled A trusts the person labeled B. So you have the edges in the graph.
Yeah.
Okay. So for every edge, when you have this edge, what does that edge affect the in degree?
Wait, the edges are the arrows.
Yeah,
Okay. Yeah, so edges and nodes, or edges and vertices. What's
edges. Edges are arrows.
mhm,
This is an edge.
the circles?
Here, edge. This is a node or vertex.
Okay,
Both are correct.
okay.
And this is a directed graph.
Mhm.
So this is an edge from 0 to 1, just like here. 0, 2 goes from here to here. 0, 3 goes from here to here. Okay, when we add an edge, how does it affect the in degree of 0?
It doesn't, because it's directed. So because
Mhm.
it doesn't affect the in degree, it affects the out degree.
Of 0. It affects the out degree of 0, right?
Mhm.
And sorry, man, I had to talk to my friend. Okay, so 0, the edge 0 to 1. It affects the out degree of 0, you said, right? And what about 1? It affects the in degree or the out degree of 1?
The in degree.
Okay, and what are the modifications? What does happen to 0 and what does happen to 1? To the in degree or out degree?
So the in degree of one
Mm-hmm.
grew by one, and the out degree of zero grew by one.
Yes, that's it. For every edge, right? So when you do, for this edge, 0 to 3, you will add another out degree to 0 and another in degree to 3, right? From 0 to 2, you add an out degree to 0 and it will have 3, and you add a in degree to 2 and it will have 1. So the final result for the for this one, how much?
One,
This one?
one, and one, and zero.
Okay, what about the out degrees?
Three and zero, zero, zero.
Exactly. So do you know how to implement now?
Okay, yeah, yeah. I think that's why the adjacency list is much better. Okay, so the adjacency list is just it's the list of trust that they gave me. That's the adjacency list, isn't it?
The list of out degrees, the number of out degrees is the size of the adjacency list.
No, what I mean is I didn't really need to make a data structure because they gave me the adjacency list with or no.
That is not the adjacency list. That's the edges list.
Okay, okay. So should I delete this?
Yeah, we better do
Mm,
something different.
shit. Okay.
Okay, so
So
now the problem is how to create the in degree and out degree.
okay, we just an array of size n and use the index
Mm-hmm. Hello? Hello?
add 1 to the array in position 2, well, in position 1.
I'm sorry, you cut out. Can you repeat
Oh,
again?
sorry. Yeah, so we have the out degree and we an array of size n, and then we use the indices of the array to represent the people, and then we add 1 to oh no, we add 1 to the array in position of the first number of pair.
Mm-hmm.
Okay,
Yeah.
so um, int in degree n. Should I also make one for out degree? So we have all the in degrees and all the out degrees.
Should you what? Sorry?
Oh, so that we have the out degree, so we know how many people that person trusts, and the in degree to make sure to know how many people trust that person. Okay, equal to 0. Oh no, 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 I need. Oh no, yeah, yeah, yeah. So t is a vector of integers. Um, okay, in degree. Okay, let's start with out degree. I'll move this. In the position t, in the position 0 minus 1 plus plus, and in degree in the position t, in the position 1 minus 1 plus plus. Oh, okay.
Yes.
Uh, so now there, the two arrays are populated, and then we need to go through the out degree array to find a person with 0, so that that person trusts no one, and we need to go through the in degree, and that same person should have an in degree of n minus 1,
Mm-hmm.
right?
Yeah.
Okay, okay. um, okay, so if okay so if wait, so I go through the out degree to make sure someone has 0, an out degree of 0. But what if more than one person has an out degree of 0? Mm, because it says that exactly one person satisfies properties 1 and 2. So, but maybe like other people can satisfy just one of the conditions.
Yeah, that's right.
Okay, so ah, okay. So what I could do is um, go through the out degree array, and then for all the people who trust zero people just check those values, those indices in the in-degree array, and only one should meet the second condition. And if no one meets the second condition, then I just return -1.
Yep.
Okay. But how so should I use a vector to store the indices of all the people who trust no one? Oh, okay. I got it. I got it. Okay. So if out degree in the position I is equal to 0, then I check the in degree.
Mm-hmm.
Okay. If in degree in the position, yeah, in the position I is equal to n-1, return mm, return I+1.
Yep.
Okay, return I+1. And if this condition isn't met, if this condition isn't met, so for the so here it should be correct. I think I think it's correct.
Yeah.
Okay, let's go.
The array's initialization is a bit weird. Hello? Hello?
Oh, I'm not sure why it's taking so long.
Uh, why did you do this? What I know is like this to initialize an array.
Oh,
And there's also this one is here, out of the loop.
oh,
And you don't need, you can do this.
really?
Yeah, just check them
Ah, yeah.
together. Yeah, this looks cleaner.
Mhm. Should
See?
I reload the page?
Yeah, I guess there's a problem.
Okay, let's see if it works now. Degree and
Oh,
oh no,
of
you
n.
got
Yeah, you cannot use a variable. You have to use a constant there.
oh
Yeah.
okay.
So yeah, this solution is easy. You don't have to think a lot about it. So you either initialize the max 1000, you do 1001 or 1000 in a number, or you can simply do this like vector int in degree of size n initialized to 0. So this is a constructor of a vector.
Okay. Ooh,
Nice.
it's when 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 you explained it, it became so much easier. But I had so much trouble with it. It wasn't like
The
I didn't
vector
think about
is,
the different properties.
yeah, but it's really good that you have found out the idea on yourself by yourself. But I'm surprised why you use it Slow.
Oh, but I don't trust leetcode. It's been very bad with the runtime and the memory usage. I don't know why, but it's all over the place. Like different, I submitted different times and I get a different percentage every time. Sometimes I do like an O of n squared and I get faster than 100%. It's really weird.
Well, yeah, so in degree and L degree,
Yeah, so it's basically our solution. But
one array. Well, yeah, you can do +1 and -1. Yeah, those are some interview questions, you know. Yeah, I'm sure. I don't know why is it slow because that's an optimal solution. Anyway, if you say so, then yeah. Okay. We spent some 25 minutes on it together. If you want to add that,
yeah, should I add my time that I spent alone?
uh, okay, you can do it plus. Okay, I'm doing plus 20. Okay, let's make it a text here, not a number. Uh, 5 minutes. Okay, you said an hour and a half, 90 minutes offline plus 25 together. Judge of the town. Okay. Do you have another question you want to solve together?
Yeah, wait. It was mm, 346.
By the way, can we do less than 2 hours today? Maybe an hour and a half, something like that, because I'm extremely, extremely tired.
Yeah, don't worry, no problem.
Okay.
Wait, did I?
Okay.
Congratulate. Yeah, maybe not this one because it's creating a class. I think I can. I don't know why I wrote it down then. Yeah, no, that was the only other one that I thought we could do together, but yeah, I don't know why I wrote it down. Ah, no, wait, I have one saved on. I don't know where they're saved. Topics, companies. No, mm-mm. No, I don't have any more.
Okay.
Should we do easy, medium?
You want to do that problem together?
Which one?
The one that you just showed me, the moving average.
Oh, no, because it's creating a class, and I think that with like object-oriented programming, I'm pretty good. I'm mostly worried about the data structures and
Yeah, there's some optimization there.
yeah,
Did you
okay,
find it out? It's more about algorithms than about object oriented actually.
okay. So given a stream of integers and a oh yeah, I remember. Yeah. So given a stream of integers and a window size, calculate the moving average of all the integers in the sliding window. Implement the moving average class. Moving average in size initialize the object. Mhm. Double next size values of the string. Okay, okay. So, ooh, returns the moving average of the last size values of the string. Okay.
First, let's think about the brute force.
Mhm. Initialize the object with the size of the window size.
Hmm.
So should I make like
I don't
so?
think you have to do that, but it's fine. You can. I don't know. I think you just have to do it inside the moving average.
Okay. So next. Wait, I'm having like trouble wrapping my head around the problem. So
First,
an
think about the
object,
easiest solution. Just easiest solution that you can find. We can optimize later.
is I don't know what a string of integers. Okay, so I initialize moving average with a size 5, let's say, and then I receive 5 integers,
A
or
string of integers, that means that you have a fixed size of a window, let's say 5, and when you add a sixth one, you're gonna have to delete the first one.
okay, so we could use a queue.
Okay?
Yeah, is it like a queue or a stack? Uh,
It's a
First
stack.
in,
It's a queue, I'm sorry. It's a FIFO. First in, first out.
okay. I am completely blocked. I'm sorry.
You wanna do another one?
No, it's okay. I'll get it done.
Mm-hmm. Okay.
Okay, so okay, so here, um, so I need to create a queue of integers. Oh, do I give it a size? No, I don't. I don't need to give it a size. Um, Queue. And then, so in next, I'm going to need an if. So if q dot size is equal to size, dot pop, and then
Uh, I actually, I just have looked at the solution. I don't know the optimal one, to be quite honest with you. I've had an idea, but it was not the most optimal one. Um, the problem is not bad. It contains some optimization, but I think that we can find some better problems that we can
yeah,
solve, and you can learn better from them.
okay, yeah. Um, so let's do easy, and then let's go like,
Yeah, let's do the easy and sort by acceptance as usual, and let's try to go for the most optimal solution.
okay,
Okay, can you go up? I want to see how you solve some problems. Yeah, still. Can you still go up?
okay,
Okay, hold on. Shuffle the array richest customer. Okay, you want to try shuffle string?
shovel string, okay, okay. Given a string s and an integer array indices of the same length, the string s will be shuffled such that the ith character position moves to indices I in the shuffled string, return the shuffled string. Okay, wait, let me try that.
Okay, you have 10 minutes to solve this one.
Oh, okay, okay. Um, so, okay, so I have S as igual a code lead, then in this for, okay, so this is in 0, 1, 2, 3, 4. So, okay. Um, yeah, I'll just do, wait, get, okay, yeah, I figured it out. Okay, so,
Mhm.
mm, shuffles. Oh, oh, no, no, I got it.
7 minutes.
So,
Six minutes.
ooh, I don't know if you can do this to a string,
Yeah,
but
you can.
oh, oh wait, ooh, how did I do?
At the start, I was gonna tell you I was gonna give you 5 minutes, but then I said, "Hmm, maybe, maybe I don't know, because I think it's a 5 minutes problem, not more.
Yeah, but
Uh,
I was thinking I was gonna do like an array, but no.
yeah, yeah, you don't need that. Um, yeah, and you can actually create a string. You can also do as the same as vector. You can do something like this. Initialize of size, uh, s dot size.
Oh, really?
Yeah, it's gonna
Okay.
be all A's.
Mhm.
Yeah, just something good to know. It's like vector. You can do vector int n n0. So it's gonna be
Mhm.
vector of n zeros, and here s dot size A's. Okay, hold on. Can I see the solution of jewels and stones?
Jewels and stones. Okay. Oh yeah, I jewels and stones. This one I didn't do on my own. I
Okay. So this is not the optimal solution.
uh-huh. Yeah, I because this was my solution, and then I checked on the discussion and on YouTube, and I found the like hash map solution.
Mm-hmm.
But yeah, like just so you know that it, because I think I ended up submitting my yeah several solutions, but like the good ones are the ones with hash maps, but like I didn't come up with that solution. So
Okay.
wait,
Yeah,
let me check.
I actually think you're good with implementation, and we can do some recursive problems.
Oh yeah, yeah, honored set.
Yeah. How do you feel about um some recursive problems?
Okay, yeah,
Okay. I'm gonna give you co-chair. So now we're gonna solve our problems. It's not gonna be lead code,
okay,
but we're gonna use lead code later. So here's the link. Uh, Here it is. So then generate a list. print all combinations of zeros and one of strings of length n. Example, n equal to input, output, 0, 0, 0, 1. Do you get the idea?
Yeah, yeah.
Can you do that?
Okay. Um, so I mhm.
Yeah.
Recursively. Mm,
You don't have to do it recursively.
no?
You don't have to. You can solve it recursively, and you can solve it not recursively.
Okay.
But one of them is an easier solution than the other.
Okay. So wait, is it going to compile?
And no, it doesn't compile.
Okay, so
You don't have to. Okay, okay, okay. No problem. No
just
problem.
the solution. Okay.
Yeah, it's awesome. You can follow the leetcode architecture, or you don't have to. I'm just saying, even though that it's not exactly the same as
Mhm.
leetcode because they have a class. You didn't create a class, but anyway.
Okay, I'm just going to create a function so that I can call it
Hmm.
mm, mm,
Let me know what you think, by the way.
okay. So I'm thinking do the first character and then call the the function with n minus one, but I'm not sure how we would print like okay. So what I'm thinking would output like oh wait I'm having mm, ooh maybe well what I could do is if the input is 3, what I need to output are all binary numbers up to 2 to the 3.
That's true.
So,
Hmm.
oh, so, okay. Ah, no, 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 no. Yeah, okay.
That's a
So,
good way to go.
okay. Mm. Oh, okay. Okay. Maybe I can output these four, then these two, then this one, and then this one.
The order
If,
doesn't matter.
okay, so int, so noms, like the quantity is going to be two, which is like pow, 2n minus pow, 2n minus 1. Oh, but that's, oh, no, 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 no. The base case. If it's recursive, I should have like a base case. So if n is equal to 0, oh wait, uh, and if n is equal to 1, uh, oh wait, this should be more intent. Okay, wait, so it's gonna be else,
But why are you assuming that the length is 3?
sorry?
The length is n. The length of the strings n. So is 0
Oh,
here is 3 zeros here.
yeah, yeah. Ooh. Oh, okay. So maybe I should have a string of zeros of size n. Wait, I'm gonna write it down so that I can. Um, okay.
Let me know, what are you thinking of? What is
Wait,
stopping you from implementing? Where is the problem?
because so I have int n
Hmm.
but I don't need to print n. I need to print 2 to the n. So it's
Mm-hmm.
okay. So I have 2 to the n, and then I say and then I call a function that says print the uh, the current number in binary, and then call that function with n minus 1. Well, not n minus 1, but the variable that I assign 2 to the n to. Wait. Okay, so what I was thinking is int nums is equal to pow 2 to the n. Okay,
Okay.
I don't know how to print like in this size, because if I say print um so if I print 8, well 7, it's gonna be it's gonna be 3 digits long, but then it'll go down to 2 and then to 1. So instead of being like 0, 0, 1, it's just gonna be 1. Because what I'm thinking is just like have a function that says print nums in binary, and
Mm-hmm.
then uh, call that function with nums minus 1. But that'll that will not print like 0, 0, 1. It'll just print 1, or 0, 1, 0. It'll just 1, 0.
Okay. Do you are you good with like combinations and permutations, the probabilities and stuff like that?
I took a statistics class in high school, but that's about it.
Okay. Um. Okay. So your approach is correct, but you're going to the path where the implementation is not very easy. So, but that's one way to solve it, and I'll explain it maybe later. The implementation is not the easiest. The easiest is the recursive implementation. Once you're comfortable with recursiveness, if you're good with recursive functions, you can code it in 2 minutes. That's it. But in order for you to do that, to do it in 2 minutes, you need to be comfortable with recursive functions. So you said it's 2 to the n. That's 2 to the um, okay. First, why is it 2 to the n, not n squared? Why not 3 to the n?
Because it's zeros and ones. So because it's just 2 digits,
Mm-hmm.
it's the so it's 2 because you can only have 2 digits, and then n because it's the length of the of the number. So the maximum you can have is
Mm-hmm.
2 to the n. If all the numbers are 1, 1, 1, 1, 1, then that's the maximum you can have.
Okay. Now I want you to pay attention to this. Uh, okay, so this is like empty character. Don't consider that a thing. Okay, so you said that we have two options. We either go with the
Mhm.
0 or 1.
Mhm.
Okay, so when you look at this tree, this one, for example, you have 0, 0, then 0, 1, then 1, 0, then 1, 1. So it's like you have a tree, and for each tree, it's like a complete binary search tree.
Mhm.
And the number of nodes in a complete binary search tree is to the n, right?
Mhm.
Are you sure about that? Do you remember binary search tree complete?
Yeah, and the number of levels is log n. Wait, yeah, isn't it?
It's complete is either so yeah, like this one.
Mhm.
Oh, it's full. I meant full. So here we
What's
have
the
two teeth.
difference?
Sorry.
What's the difference between full and complete binary trees?
Complete, I guess. Mm, yes. Actually, what I meant is this one. You don't have to remember the definitions, by the way. Perfect binary tree.
Oh, okay. So all the nodes have two children, and yeah,
Yeah,
they're all in the same level.
yeah, exactly. That's a perfect binary search
Okay.
tree. And the number of nodes in a binary search tree is 2 to the n.
Mhm.
Okay. So here in our case, it's like a perfect binary tree, and it's like you go n paths or you make n decisions, and for every decision you have two scenarios. Scenario number one is you pick O, then O. Scenario number two is O1, 3, 1, O, 4, 1, 1.
So so I have n decisions.
Mhm.
So should I create a binary tree?
No?
Mm, okay. Mm, so have I so okay, so first would be 1 1 1 1. Then it would be, wait, so I would go all the way. No, I would start all the way with all the digits one and then go, but I don't know how I would use recursion there.
Mm, okay. Okay, you don't know how to use recursion.
Well,
Oh. Okay, imagine that it's a binary search tree.
mhm,
Imagine it's there already,
mhm.
and you have to go over the nodes of the tree, and at the end, when you're at a leaf, you print the results.
Okay, okay, okay. So, um,
Don't create it, but imagine that it's already there. So imagine that we have, you know, something like struct node int val node left.
mhm. Ah, okay. So I start with an empty string
Mm-hmm.
and then I call two recursive functions, one with 0, one with 1, and then
Yes.
okay.
Nice.
So, oh no, it should be, oh no, wait, I don't need to have this. And then I call, I call, sol, um, oh, wait, so I have n decisions, n decisions. Ah, oh, I hate recursion.
And you will love it. You'll see. Everyone hates it at the start, but then when you master it, you're gonna love it.
So but I don't know how to make the decision. Like, how do I decide if I put a 1 or a 0?
You always have two decisions. You put a zero and you put a one.
So should I have another string?
Not necessarily a string, but in recursivity, you have to look at the recurrency relationship. You have to look you have to spot where you're pretty much doing the same thing over and over again.
Mhm,
So here, for example, you're doing this, and then if we go further in the tree,
mhm.
something like this. What?
Well,
and you finish by having, you also like do 0 1 0 1 0 1 0 1.
Mhm.
If you follow this case, you'll see that it's going to be generating this.
Mhm. Yeah, but what I don't understand is, okay, so I start on the dot with an empty string, and then I, oh, then I call the, oh, wait, okay, okay, wait,
Show me, okay.
what, so, no, I need to create another function that I can call recursive. This
Yeah,
solution, okay, so, so call solution helper, 0, and solution helper, wait, but that's not recursive yet. Okay. And then, oh wait, so I'm not even, ah, okay.
okay.
So
You're getting closer.
S and S, and then
Mm-hmm. Yes, yes.
void solution helper S and B,
What's B?
binary.
Okay. Okay.
So
Think of the base case.
all zeros,
All
or
zeros?
all, or all ones,
Oh,
or the base case, no. Wait. Oh, an empty string.
no. The base case for the recursive function. When do you return? The base case, look, here you make a decision and
Mhm.
you go further, deeper in the tree. But here you return, you stop. Here, this is a base case. This is a leaf in the tree.
So when right and left are no pointers.
uh,
I, I,
okay, okay, yeah. Okay, start with that.
so,
It's fine. Okay,
no,
so
no, 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 no. But so it would be
I'm gonna help you.
like,
Look, I'm gonna do this. Node root, and here you have S. Okay, so the base case is when new node left equal null and node right equal null. What do you have to do?
return print S.
Okay, yeah, go ahead. Otherwise,
Mm, so S 0. But I don't know if I should add the 0 or the 1. Oh wait, oh wait.
when you go left, you add 0. When you go right, you add 1.
When you go right, okay, wait. I I think I'm getting somewhere. Ah, okay. Uh-huh. Uh-huh. So root dot left. I don't even remember how pointers work. Ah,
Doesn't matter.
so
I'll be correcting
so
you. The syntax is on
s
me. I just need the code.
one or in one and um
The zero is on the left.
oh
The one is on the right.
uh-huh.
Okay.
Okay.
Yeah, keep thinking. I'm gonna correct this.
Wait, so it's um that's it?
That's it with the binary search tree. This is correct.
Oh, okay, so now I need to find without.
Yeah, but do
Okay.
you do you understand why this is correct?
Yeah, yeah, yeah. Because if there's no more numbers to like no more leave well no more children
Hmm.
nodes to visit, well it just prints. Otherwise it recursively adds the numbers.
Yeah.
Okay, so now without
Okay.
the
So now you have to we remove this. You don't have node. You don't have this. You don't have this. But you have this. This
yeah, but
stays. The rest has to be changed.
I got it. Wait, but how do I wait? So if n is equal to 0, yeah,
You
doesn't
think
it?
it's correct?
Wait. Let me. Okay, so
We can try it. You can go on leetcode. We can copy this. Hold on, hold on.
oh,
Was it me?
wait, yeah,
Okay,
it.
sorry. Just let me
Mhm.
copy this. Let's go to the playground. Okay, try it.
Okay, so yeah, and it doesn't. And oh, yeah. So n s wait, void string s equal to and S.
I think it has to be declared up. Says undeclared. That's the only.
So, oh, oh,
Good job. Nice. Really well done. You did an amazing job.
really?
Yes. Okay. We're not done. We're not done. So now I want you to generate the same thing, but with digits. Here I said digits 0, 1. I want now 0, 1, and 2.
Okay, wait, wait, this is killing my computer. Oh, yeah, let's say, okay. So, okay, a lot easier. Um,
Then you thought, right?
no, no, no. To add the two. No, the well,
Oh, okay, okay.
it's like it's easier when you've done it already. But yeah.
Yeah.
So again, solution helper n minus one s plus two, and yeah, yeah.
Yeah, right. Yeah, well done.
Oh,
Good job.
wait.
Okay, now let's discuss the time complexity and memory complexity. Let's come
Okay.
here.
So what I remember is when it's recursive, it's the like the number of calls by the depth. So it would be the time complexity would be 2 to the n
Mhm.
for the 0 and 1, or 3 to the n for the 0, 1, and 2.
Exactly. Right. Yeah, you can
And the
answer.
memory
You can write
complexity,
that.
okay, time complexity would be O to the n, and the memory complexity, I don't know. Recursively, I know that recursion can take a lot of memory complexity because it has to like store all these different states. Um, so maybe it would be 2 to the n also.
Yeah, but why 2 to the end? You have to explain.
Well, because here where we have to call 2 times, and then so it's 2 states, and then those 2 states call 2 more.
Yeah.
Yeah, because it yes, because that's the that time that it has to store the numbers before it prints.
Mm,
Yeah, I don't.
okay. Hold on. Let me let me try something. There's no debugger here.
I don't know. Oh, sorry.
Mm,
Or okay, it's 2 to the n because it has to to save every single number or like every single pass in memory, because sequentially it would just have to I don't know.
Okay. Uh, okay, let's explain it this way. So, do you know how this stack works? The memory
How
stack.
the stack?
Yeah.
Yes, it
Not the stack data structure, but with the recursivity stack.
no.
Okay. So when we start here, we have two parameters. We have n and s. So we will start with n, let's say 2. Let's say, I'm going to call the function 2, and here, that's an empty string.
Mhm,
And then gen of 2, we'll call gen of 1 with 0,
mhm.
because it's on the left. And here there's gen of 1, 1. Mm, okay, after that, what happens?
It prints.
Here, we have gen of 0,
Okay, and 0 0, and then the same but 1 0.
0, 1 actually.
Oh yeah, 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 0 1, and yeah, 1 0, and then 1 1.
Gen 0, 1, 0, then gen of 0, 1 here. Okay, so what this stack does, that it saves the state of every call. So here,
Mhm,
2 with empty string, it saves it, and it pushes this one. It works
mhm,
on this one, then it pushes this one. It goes deep.
mhm,
Then it reaches the um, base case. Sorry, the base
mhm,
case here. It prints and then it pops. It pops this one. What's left in the stack? The last one pushed is this one. So it returns this one. And after this one, it pushes this one and it comes to this one.
Ah, okay. So then it comes to this one, the Gen 2, and then it, oh no, because it only pushes. Ah, then it goes to the other side of the tree.
Yeah. The thing is with this stack is at the same time, at most, n functions are saved. N functions at the same time.
And
N. Yes, this is n. 2, 1, 0. So it's n plus 1, kind of. So
okay.
it's related to n. It's
Mhm.
linear by n of functions, the number of
Right.
functions, okay? So We save this, we go here, but when we go here, we don't save this in the stack. We pop it from the stack.
Mm-hmm.
We go like this, here and then here. And when we go here, this is already popped. And then we
Oh.
pop and go here, and then we pop, we go here, and then we go here, and then we go here. We push.
Mm-hmm.
So we have three pushed at the side. And then we pop this
Okay.
one, base case. At every base case, you pop, you get back here, you push, you're here. And but by the time you're already here, this is popped, this is popped, popped, popped. Everything is popped.
Mm-hmm.
What's left is the this function and any function and what's behind it and its
Mm-hmm.
parent, every parent,
Okay.
until it reaches the root
So it would be n, well, n plus one. So
of n.
n. Mm-hmm.
Yeah,
Oh, okay. Yeah,
that's what
yeah.
happens in the stack.
So it would be,
But
oh,
there is one thing.
oh.
Yeah, there is one thing that's um here. What's gonna be pushed in this stack? This string.
Mm.
We're gonna be pushing here. String of length 1 plus 2 plus 3 plus n. Because look at the string. It's growing every time.
Mm-hmm.
We're not pushing an integer.
Mm-hmm.
And what is this?
Uh, some
Yeah, sum of 4.
integers.
Yeah, it has a formula. This one.
Oh, factorial. Oh, no, no, no,
No,
that's not. No, 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 no. Sigma.
sigma.
Yeah, like the E. I don't know what you're
Expectation.
asking. Sorry.
It's the arithmetic sum. N times n plus 1 over 2. You don't know the arithmetic sum? No?
I maybe I that's yeah, that's statistics class in high school.
It's fine.
Yes, I
Okay. It's this one. So it's the first term plus the nth term. And here, the first term is 1. The nth term is n. Hence it becomes n times n plus n, 1 plus n, sorry, over 2.
okay.
And it's the same complexity as this code. So when you write this, what's the complexity here?
N squared. Well, no, 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 no. Oh yeah, N squared. Mm,
Okay, if I change this to this,
it would still be N squared
why?
because like it would average out to to have, because like you would do all the passes in I and then start with all the passes in J and then n minus 1 passes in J and then n minus 2. So it would be I times J over 2. No, so it would be n times n divided by 2. So yeah, it would be.
It is n squared, and it's the exact same formula as the arithmetic sum.
Mm,
Because look, we have 3 starting with 0, we have 2 starting with 1, and we have 1 with 2. So it's like you have n plus n minus 1 plus n minus 2 plus 2 plus 1. The first n is this, and then the n minus 1 is this, and the n minus 2 is this, and this formula is n times n plus n over 2, which is O of n squared.
mhm. So so is it, so it's n squared?
Yeah, with this one is n squared,
Oh.
with the buffer like this,
Mhm.
but we can make it n.
How?
Good question. If this string becomes like this, and we do this, this is going to show you, another trick. So S, push back, C, S, proper, and between them you do solution helper n minus 1 S. So the difference is we have made solution S a global. Well, this is not global, but it's not in this function. It's not in the recursive
Okay.
call, so it's not
Yeah, yeah.
stacked out.
Mm-hmm.
So let's go to the program.
Ah, okay, okay. I'm getting your solution.
Um, yes. Mm, and declared.
Oh, you have to remove the,
Yeah.
yeah. In the 16, you have solution helper S0 and S1. What do you think?
So this gives the same result, but this
Mhm.
one is of n memory
Okay.
because we save it, we save the buffer or the result in a global variable. And this is gonna store this stores and characters. But
Yeah, yeah.
if you make it here, you're gonna have uh n stacks, and within n stacks of strings, the first one is of length 0, the second one is length 1 to
Mhm.
the n, and that stacks up to make of n squared.
Mhm.
Clear?
Yeah. Well,
Yeah.
yeah, yeah. It's complicated, but yeah.
Uh, okay, mm, let's save it. Okay. I think we're good with for today.
Yeah,
Try to work
perfect.
on recursive problems. I have some. I'll create a document. I have some problems. I don't know if I've showed them to you or not, but I have a list of recursive problems. They're very good, to have a solid base in recursive and recursivity to make it easier for
Perfect.
you to solve harder recursive problems.
Perfect. Yeah.
Okay. Yeah.
Mhm.
I thought that I shared them with you. No, I
You
only.
shared the Excel for
Yeah,
the problems I
I have a
do.
doc. Let me find it. Some, I don't know why I didn't do it for you. I'll copy. Okay, so today let's just count 1 hour and a half. Okay.
Okay. And I owe you last class. I owe you this class.
Yeah, 2 classes.
I don't know where I pay.
Oh, Code Mentor,
So
the platform.
does it? So do I go to your profile or how do I?
Yeah. Okay. Can I show you?
Yeah, sure.
Okay. So you go here. Yeah. You can hire me,
Oh,
but
okay.
you don't have to do that. You can simply send me direct
Sender.
payment. Yeah.
Okay, perfect.
So with direct payment, you literally send me the amount, and that's it.
Okay, perfect. Mhm.
I just shared it with you.
Okay. Wait, let me. Okay, yeah, I got it.
Mhm.
Okay, yeah. Hmm.
Okay. So if you don't understand something with the problem,
Sorry.
let me know. I said if you don't understand something related to the problem, let me know.
Okay, yeah, perfect.
Okay. Uh,
So I'll schedule same time next week.
yeah, sure. Yeah, I hope you don't mind, making it from around this time. So it's not 4 p.m. already. No, well, it's like, I mean, 4 p.m. my time.
Hmm.
But, it's at the same time you scheduled, at the same time you started today. So schedule
Yeah.
then, and I'll just move it,
Hmm.
I'll push it
Okay,
30 or 40 minutes at most.
perfect. Yeah, don't worry.
Okay. Okay. Yeah.
Okay, perfect.
So yeah, really well done. I think you're making some progress, and over time, I'm sure that you will make an amazing progress. Yeah, you're actually very smart, and you understand pretty fast, and you have really, really good thinking skills. Your thinking skills are very, very good. You have to be
Thank you.
grateful for that, and you should be also try to work hard to use your potential to the maximum. You know, because you have potential. You really do.
Okay. Yeah. I'll this week I'll study hard.
Okay. Awesome. Awesome. Great. Okay. So please don't forget to send the payment. So 2 hours for the previous session and 1 hour and a half for this one.
Hmm. No
Okay.
problem. I'll do this right away.
Okay. Thank you so much, Samuel. See you
Okay.
next week.
See you next week. Bye.
Bye.